That's right. I turned my logo into a neat little device that notifies me every time someone views or likes any of my videos. If you want to see how I build it, stay tuned. Hello fellow humans! As already introduced, I will walk you through the build process of this nifty little device I built myself here. Now that I'm a new YouTube fanboy, basically after the 2 videos I have, I crave for every like and subscription and view of any of my videos. I turned my logo into a neat little device that notifies me every time someone views or likes any of my videos. So if you're watching this right now, take a moment and hit the like button, hit the subscribe button, and follow me through the rest of this build. In today's episode, I'll walk you through the complete design process from the idea to the finished product you see here. We'll first start with the design of the parts and also the inspiration I got for them in OpenSCAD and Blender. Afterwards, we'll talk a little bit about the assembly process, the electronics, and then shortly about the code. The idea for this device came while watching one of the videos of Gear Down for What, who was talking about circulating ball bearings. I set off, I'm not that good with Fusion 360, so basically I turned to OpenSCAD, my tool of choice for these kind of things, and designed my first gear, which looked like this. Which doesn't spin that well and doesn't work that well and isn't that good overall, but it was a start. So after that, I wanted to turn my logo into using this mechanism for the display you just saw. So the second iteration was a little larger. It's losing balls. And still has the open hole in the bottom, which you can see here, but it turns quite well. The basic idea with these kind of bearings is that you have 2 parts and each has half of a channel, and in the middle go the balls. These are BB balls, they are 4.5 millimeters. At this point I'm not able to separate both, but if I remove the balls, now that most of the balls are removed, I can show you the mechanism. On the inside of this gear you can see the small channel. So these balls fit in like here and then rotate. And we also have one of these channels on the outside of this one. So when I put these 2 together and fill the gap with balls through this little hole in here, this will fill the channel with balls, hold both of these parts together and allow them to rotate around this ball. Now for talking about the design process and how all these parts fit together and how I designed them from idea to these parts. I could take apart this device, which is something that will never happen again. And instead I'll walk you through the parts and how they fit in a 3D simulation I created with Blender. Alright, here we are in Blender now. I imported all the STL files of the objects I designed with OpenSCAD. I'm not sure if everyone is aware of this, but you can import STL files into Blender, assign materials, and then create simulations, 3D simulations, render them like the one you just saw. You can even animate them. Okay, now the build process. First thing we are talking about is the outer gear and the drivetrain. So I'll turn off the display of the display and the display lid, and we can look inside the mechanism. As I've already demonstrated you on the printed part, we have the bottom part as well as the top part of the gear, and this one is a drivetrain that will fit on a servo and rotate the outer gear. Now if we also take the small gear and separate these two, comes nicely apart, and we see the ball bearings I mentioned that fit into this channel of the lower part. You and scroll even closer. So they fit in here, and in the top we have the corresponding channel, which is on the inside. And this allows both to fit together, stick together, and rotate the outer gear. On top of this, as you've seen in the bottom, we have these pillars that allow us to mount the display lid as well as the display in a fixed position while allowing the outer gear to rotate around them, which gives the cool effect, I think. All of the parts you just saw I 3D printed in PLA on my CR10S. But in the last few days I realized that when I'm capturing time lapses at full HD resolution, I have Octopi running on a Raspberry Pi 2. This kind of overloads the resources of the Raspberry Pi 2, causing Octoprint not being able to deliver all the commands in time to the printer, which in turn causes the printhead to pause at certain points, which causes really rough prints. And by turning off the time-lapse capturing function, my prints are smoother now, very far smoother than before. Now for the electronics. In here is an Arduino Nano version 3, a 1.8 inch TFT display, as well as a L293D motor driver. Now I used a very small hobby servo that I modify for continuous rotation for this task. I wanted to do this because it's geared, so I have a little bit more power, because I didn't know how big I wanted to print this. And the L293D you need because you can't directly drive a motor, even a very small motor, from the output pins of your Arduino. So what you want to do is you want to connect this L293D to the 5-volt line of the Arduino, which basically comes from USB. And only do that if you know that your motor will take less than 500 milliamperes. How does this Arduino know when we get a like or view or a subscription on YouTube, you ask? That's pretty easy actually, because of the YouTube API, which we can query using a script on the PC. So currently the Arduino is connected via USB to the computer, and we can open up a serial connection and just send the current statistical values to the Arduino, which in turn will react whenever something changes. It's pretty easy, right? In the next iteration I plan on using an ESP chip, which will connect over Wi-Fi to my router, which also has the possibility to run a script on board without any external computer. That'll be pretty amazing, and I'll upload the code whenever it's finished. I'm actually amazed at how good this turned out in the end, and as always, all the 3D printed parts, the code files and the parts list of the parts I used can be found down below in the description. And if you enjoyed today's episode as much as I did, I love it when it does that. Look at that, it's amazing. I love it every time. So if you didn't do that already, hit like, hit subscribe on this video and keep on watching. Bye bye.